Welcome to qnawire.
So here in this problem we have to find the initial mass of the ice for the given condition, and we are given that a cooking vessel contains mass of water of 10 kg and an unknown mass of ice, and let the unknown mass of ice be mi, that we have to calculate, and both of them are at temperature 0 degrees Celsius at time t equals to 0. Now the temperature of the mixture rises as the time increases, and we are given a plot also for the temperature and time graph. So let us draw that graph first. So this is the graph given for temperature time graph, and at this time, this is 50 minutes. From 50 to 60 minutes, the temperature of the mixture rises by 2 degrees Celsius. You can observe in the graph also. So let us start with the solution. So we know that in this period from 0 to 50, the ice is melting because temperature is not increasing. That means ice will be melting. Now we can apply the conservation of energy, that power supplied times the multiplied with time, it will be equals to heat lost by the ice. So P for this period time is 50 minutes. So we can write 50 minutes here, and Q is M of ice into latent heat of fusion. And we know that the latent heat of fusion in case of ice, it is 3.33 into 10 to the power 5 joule per kg. And mi we have to find out, so we can write this equation as P into 50 minutes is equals to mi times 3.33 into 10 to the power 5 joule per kg. So now I'll be considering this case when the time is from 50 minute to 60 minute, and in this case also the energy goes into the system at a constant rate P. So again, by using the conservation of energy, we can write that P into delta T is equals to Q, and Q in this case will be MC delta T. So mass here is both we have to take the mass of ice also and the water also. That means M of water plus M of ice into the specific heat, and specific heat is, we know, it is 4186, it's 6 joule per kg degree Celsius, and the change in temperature is 2 degrees Celsius. So it will be equals to P delta T here is 10 minutes. So 10 minutes. And mass of water we have already given, it's 10 kg, so we can write 10 kg here. So from here, after simplification, we'll get P into 10 minutes is equals to 83.7 kilojoule plus 8.37 kilojoule per kg times mi, and mi is the mass of ice that we have to find out. So from here we can write that or we can do one thing. Okay, let me do this way only, that from here P is equals to mi times 3.33 into 10 to the power 5 joule per kg divided by 50 minutes. So we can plug the value of P in this equation, this one. So when I plug P in this, we get mi times 3.33 into 10 to the power 5 joule per kg, and it's divided by 50 minutes and is multiplied by this 10 minutes. This is as it is, and it will be equals to 83.7 kilojoule plus 8.37 kilojoule per kg times mi. So here this 10 minute and 50 minutes will cancel out, and we are left in the denominator as 5. From here, if we simplify this, we'll get mi is equals to 83.7 kilojoule divide by 66.6 minus 8.37. It's kilojoule per kg, and after dividing the two terms we'll get 1.44 kg. So finally we can conclude that the unknown mass of ice was 1.44 kg. So this is the final result. I hope you got the problem. Thank you.